All right, so we did our horizontal and our vertical. We're also going to start dealing with systems of these. So the one thing I will say is if you might want to, I don't know, you're either going to have to stop like scribbling everything and to see where they overlap or use colored pencils or something. I don't know, pick something. Because on something like example 2, you need to know which section is the shaded, like the solution area. And so it's not going to be all the pieces. So if I look at it, something like 2, first off, how do I graph something like this? Like a normal line, yeah. Where do I start it? Up 10, and I do a slope of what?
Negative 2 over 1.
Okay, so I go down 2 over 1, down 2 over 1, so on. Do I connect those with a dotted or a solid line?
Solid.
Okay, so I have my solid line on this one. And then which way on this one do I shade? Above the line. If you're, and again, you don't have to admit this or anything, but if you get confused about which side is above or below when it's like, pick any point on the line. So here is a point on the line. If I'm supposed to shade above that, draw an arrow straight up. Above that side. Okay, so even though it's can look a little funny if it's like angled different ways, pick any point if you're supposed to shade above and draw an arrow up. That's the area you should shade. If it's below, you should draw any arrow down. Okay, and that's your area. So then this one, I do the same thing. It is x minus 2. So I start at down 2. Okay, I do my slope of 1. Does this have a dashed or a solid?
Solid.
Also solid line. And then this one is also above. So again, if I'm confused about the above or below, here is an arrow up from that line. Above the line is that side. So now what officially is my solution area for this?
The area between the two lines.
Yeah, the one that has both colors in it, right? So this is my solution area in here. Okay? All right. So, now, we're going to look at 3 of these on this third one. So before I can graph this third one, what do I have to do with that first equation?
Equals 1.
Yep. So take a minute and go solve this for y. Actually, before I do that, make this 60 the number 18.
No.
Yeah, because it's going to be like a massive...
No, it's not.
No?
No, it's not.
It's not?
Because you divide it by 2, you get 30, and then you divide by 3.
No.
You only divide.
You get like, you get 20. 20 is a little bit too big to graph.
I don't know why.
Let's
All right.
15. I can
Yeah, so then it's 20.
All right, so real quick, check that. Ben also just asked, do you have to shade for all of them where you shade above the whole horizontal, to the right of the whole vertical, and below the whole other one? No. Like if you can look at that and say, this is my answer section, I'm good with you just shading the answer section. Does that make sense? All right. So that it is easier next class, okay? I promise it will be easier because of that, okay? This is not hardly anything different except it adds one additional step at the end, okay? I want to have you have enough time for your quiz and then to do like the word problem-y part of this without having to do all of it. And that was very short. All right, so real quick, here's what I want you to do. This example is where like matrices and systems comes down to actually like business applications. And it's maximizing things, maximizing price, maximizing profit, minimizing cost, that kind of thing. So what I'd like for you to do is based off of what we just talked about, take this equation and solve it for y. Take this equation and solve it for y and graph all 4 of those. I gave you a nice big graph. Okay? Right. So maximize the objective function P. So let's say this is a profit function.
You have to redraw it.
No, you don't have to redraw it. All you have to do is plug in a couple numbers. That's it. Okay? So in this shaded region has 4 corners, yes?
Yeah.
If you had to pick out the 4 corner points of that shaded region, we have what?
It's 4 corners?
There's 0, 0.
So it has a corner right here at 0, 0.
0, 0, 4, comma 0.
This one right here.
And then 0, comma 4, and then 2, 3, comma 2, which I said before.
Okay.
0, 4.
No, 3,
3, 2.
That's what I just said.
All right. Are we all okay with the 4 corners? It's these 4 corners here that I've drawn in black here. Yes? Any issue with our 4 corners?
Nope.
Okay, so we write down our points from our 4 corners. And then you plug them into the P function. So I go and I say, okay, P of 0, 0 is obviously going to give me what? 0. P of 0, comma 4 is going to be 3 times 0 plus 4, or 4. What about P of 4, comma 0?
Is it gonna be 4 again?
No, because where's the 4 going into this time? There you go. 3 times 4 plus 0. This time it is 12. And last but not least, P of 3, comma 2. 3 times 3 plus 2 gives me 11. Which one is the biggest?
12.
12.
This is your maximum then. That's it.
No thanks.
Okay? So all you're actually going to do on this until we get to word problems is graph them, find the corner points, plug them in. It will either say maximize, in which case you choose the biggest one,
Or minimize.
minimize, which you choose the
Heck yeah.
smallest one. Okay? There is one on the homework that I want to talk about with you. So we'll go there.